Okay, the quotient rule. And there's a dirty little secret about the quotient rule, and that is that it is actually secretly just the product, the product and chain rules together. Like you need both the product and the chain rule, or you can just use the quotient rule. This is in your formula book, so you don't have to memorize using the product and chain rule, but sometimes people like that. And in fact, one of the exercises I might make you guys do at some point is proving this, or maybe I'll do that later in the video. Who knows? Anyways, I'm going to use an example again from your book, and this is going to be example 14 on page 447. Caveat that this one x cannot be equal to -1. There's going to be an asymptote there, so just, be aware of that. Okay, so in this case, our u function is going to be this x squared plus 3, and our v function is going to be the denominator of x plus 1, and there really is no other way for us to simplify this. We could split it up and say x squared over x plus 1 plus 3 over x plus 1, but then you still got that x squared over x plus 1. So let's just deal with it as is, okay? The derivative of this is going to be v times the derivative of u minus, and pay real close attention to this minus. It's super easy to mix up the order here, but remember, subtraction is not commutative. 8 minus 5 is not the same as 5 minus 8. So v times the derivative of u in front of u times the derivative of v, and then all of it over the derivative, or over v squared. So here's what that would look like. Let's first get our functions and their derivatives laid out so that we have them to kind of pull off of. So the derivative of x squared plus 3 is 2x. The derivative of x plus 1 is just 1. And then we're going to write the whole shebang down. So now we're going to have the derivative with respect to x is going to be v, so I'm going to use this, x plus 1 times the derivative of u, which is 2x, minus x squared plus 3, because that is u, times the derivative of v, which is in this case just 1, everything over v, which is x plus 1, squared. So really, you're just finding these and then plugging them into this formula, and that will get you the derivative, which again, this whole thing comes from being the product and the chain rules together. So now let's simplify a bit. Distributing here, we'd get 2x squared plus 2x right there, minus, and I'm going to put parentheses around this just because I don't want to screw it all up, x squared plus 3 all over x plus 1 squared. And the reason I want to not screw this up, very, very common, since I'm subtracting here, I'm subtracting both of them. So really what you could think about this as is this is like minus x squared and then minus also a 3. So now let us combine like terms in the numerator, and we would get dy dx is equal to just a single x squared, because we've got 2 of them here and a minus 1 of them here, and then we've got a plus 2x minus 3 all over x plus 1 quantity squared. And that's about as simplified as it gets for us, because even though this thing could be expanded, it's not like the x squares would end up canceling or anything like that. So this is your derivative of this thing using the quotient rule.